Do you have the question open in front of you? Yeah.
Yes. Got 1, 2, 4, and 5.
Okay. Physics, materials, density.
Yeah, next 7.
Okay. What is the first question? Can you read it, KJ?
What is the density of 5 centimeter by 10
Oh,
centimeters?
yes. Yes, go on. It's 5 centimeters by...
10 centimeters by 90 centimeters.
Okay, so...
10 by 10. 5 by 10 by 90.
Alright. So this here is a 10, and this here is a 90. It's a piece of wood, is it?
Yeah, please.
Now, I don't have the values on me. What's the density of wood that I gave you?
700.
700 kilograms per meter cubed. And the volume would be 0.05 times 0.1 times 0.9. So let's see what that is. 0.05 times 0.1 times 0.9. Quite small. 0.0045 meters cubed. So is my question the mass?
No, what is the density? Very funny question.
Yeah, it's
That is totally wrong, because it's 700 because it's wood.
Exactly.
Sorry, right, so... Oh, no, that's fine, that's fair enough, yeah. So that's fine. I'll change it. I'll make it now, what is the weight? What's the weight? So what's the formula for weight? mg. And the hang on, density is m over v. So m equals density by volume.
Yes.
So this would be density volume g. So volume I know, density I know, and g I know. So the weight of this would be 30.9 newtons. Okay? Yeah. So let me just fix that now. The question is, what is the density? Blah. What is the weight? Okay. Right. Number 2 is a trophy is made of 100 grams of gold and 200 grams of silver. What's the density? Okay.
Yeah.
Right. So it's like this. You can imagine you have your gold. How much? 200 grams. 0.2 kilograms, and then here can be your silver, and what's that? 0.1 kilograms. The density here. What's the density of gold?
No, gold is 0.1.
Oh, it's the other way around, is it?
Yeah.
Okay. What's the density of silver then?
10,500.
Okay, so then remember density equals mass over volume, and you could get, what do I really want? I want the volume here is mass over density. So therefore the volume is mass
1.9
divided by density. So the volume will be a tiny, 1.9, stop saying into, that means divide here, it's multiply. Okay. I know, but you need to get into, because you'll confuse your lecturer when you go to university. You're going to Ireland or the UK? Then definitely. 0.5, I'll say, by 10 to the minus 5 meters cubed. And likewise here, what's the density of gold? It's like 16. 19320. So then again, you get volume will equal 19320 divided by 0. No, I have it upside down. It's going to be 5.1760. Let me scoot this over. Times 10 to the minus 6 meters cubed. So when you mix these together, the density of the mixture is the mass of the mixture, which will be 0.3, divided by the volume. So I need to get the total volume by adding these together. So the total volume is 2.42 times 10 to the minus 5 meters cubed. So I'll put that in here. 2.42 times 10 to the minus 5.
2.42.
That's what I got on the calculator. So the density is 12383 kilograms per meter cubed.
So can I see?
Yeah. Oh, actually, yeah, it's a little bit under, isn't it?
Why it's not complete?
Wait, what now?
I got 12195.22.
For the total volume?
The total density.
What did you get?
12195.
Ah, yeah, that could just be a rounding issue. If you got somewhere near 12,000, that's great.
Yeah.
Okay, can we go on to number 3?
Yeah, sure.
Let's have a look. So, number 3. Right. So, glass of wine, 75 cl, 14% alcohol, and the non-alcoholic part is probably something like sugary water. Assuming the 86% non-alcohol has a density of salt water. Yeah.
Didn't do it. It's
haram.
haram.
Yeah, it's forbidden, I know. Right, so what's the volume here? It's 75 centiliters, which is 75 divided by 100 litres, which is, isn't it? Yeah, 0.75 of a litre. Yes? And I think we worked out the volume of a litre earlier in a different question, didn't we? What was the volume of 1 litre? It's like
0.01.
0.01 of a metre cubed, or
0.01.
2 O's, isn't it? So this would be 0.75, 0.001 of a metre cubed.
Yeah, double over.
Yeah. So that would be 0.00075 meters cubed. Now, that's 100% of the volume, is this. How much of it's alcohol?
It's 14% alcohol.
14% of the volume.
That is 10.5.
That'd be 0.1234105, and then the 86% of the volume, that would be 0.86 times 0.00075. That comes to 0.000645 meters cubed. So this is the alcoholic part and the non-alcoholic part and the total. So if you want to know the density, you need to know the total mass and the total volume. Now we know the total volume, it's right here. There it is right there. We don't know the mass, the total mass. So what I'll do is I'll work out the mass of the alcoholic part and the mass of the non-alcoholic part. So if I go to the side, remember density is mass over volume. So what's mass? Density multiplied volume. So here, the alcoholic part, the mass is, what's the density of alcohol? 789 multiplied by the volume 0.000105. So that is 789 times 0.000105. About 80 grams. 0.083. We'll just do it to the nearest gram. Kilograms. And likewise here, mass is, what's the density of the salty water? 1030, is it? 1030 times 0.000645. So here you get the mass of that part, 0.66. Yeah. 0.664 kilograms. So now we can work out the density of the bottle. It's the total mass divided by the total volume. The density of the drink. Yeah. 996 kilograms per meter cubed.
But the question on this is find the mass.
Oh, does it? Okay, so then you could have stopped here. Yeah.
Total mass.
Okay, that's fine. Yeah, so it's an 80. The total mass. Okay, sorry. So I'll write down the total mass. It was 0.664 plus 0.083. Yeah, the mass was 0.747 kilograms. Okay. Next question now. Yeah. Let's have a look here. The next one. Yes. Carbon has a density of about 2 grams per centimeter cubed. Humans are 70% water and 30% carbon. What is the volume of an 86 kilogram man? Okay. So, I don't know if we should say humans are water or salt water, mostly. I'll just say water. So, here's our human. There he is. It's a human, obviously. This is 30% carbon and then 70% water. Okay, now the density of water is 1000 kilograms per meter cubed. The density of carbon is 3 grams per centimeter cubed. Sorry, 2. Now that's easy to convert. I won't actually do it because we've done that a couple of times. So you change the grams into kilo and you know the procedure. But anyways, after you do it, you'll get the density of carbon is 2000 kilograms per meter cubed. Right, so the man, what did I ask for? His volume. So density is mass over volume. So therefore volume is mass over density. Now, we don't know, we should get the volume of the water part and the carbon part and then add them together. So the volume of water is the mass of the water plus the density of the water. And then the volume of the carbon is the mass of the carbon divided by the density of the carbon. So, do we know the density of the water? Yes. Yeah. Carbon? Yes. Mass of the carbon? Not quite. No. Mass of the water? No. But you do know that we're 30% carbon and 70% water. And this, I believe is by volume. Although I'm not 100% sure.
Excuse me, Steve.
Yeah.
You know what I did? I did like the density of the human. It's equal 70% of water and 30% of carbon, and I added them. Like 70% multiply 2000 and...
I think that might work.
It would be much easier if it doesn't work.
Yes, I know that is true. I think that does actually work that way as well. Sorry, I forgot what I'm getting. I'm getting the volume, isn't it? Yeah, okay. So now we need to try and do something with the mass of the water and the mass of the carbon. So, yeah, let me just write it down. I'm just going to call... No, we don't know the volume. Volume. 30% V. Mass of the water, we don't know. Mass of the carbon, we don't know. Yes. I think actually what you said, Karar, might be the best way to do it. But anyways, I started this way, so maybe I should continue this way. Anyways, let me put in the numbers. Volume of the water is the mass of the water divided by 1,000. And the volume of the carbon is the mass of the carbon, which we don't know, divided by 2,000. But what we do... You okay there, KJ? What's wrong?
You said, what's the volume of the 86 kg man?
Yeah,
So that's the total volume.
that's the total volume. What's the problem?
Okay.
Now we know what the total mass is. So what I could do is I could say let X equal the mass of the water and Y equal the mass of the carbon. So what is X plus Y?
X plus Y?
Yeah, it should be 86.
86.
So that is one equation. You also know that V water equals X over 1,000. So that's another equation.
Okay.
You also know that V carbon equals Y over 2,000. Yes. And you also know that he's 30% water and 70% carbon. So if you were to do something like volume of water divided by volume of carbon, that should be 70%. I mean, it should be in the same ratio, 7 to 3. So now we have another equation, VW over VC equals 7 over 3. Now, I know there's a lot here, but they'll go together quite easily. So, for example, what you could do is you could take these two and substitute them into this one. So you would have X over 1,000 over Y over 2,000 equals 7 over 3. So then you get X over Y. This would be 1,000. This would be 2,000 equals 7 over 3. The thousands cancel. You get 2x over y equals 7 over 3. You can bring the y up and the 3 up, so you get 6x minus 7y equals 0. So you have this and you have this. Can they be solved? Yeah, that's very easy to solve. It's just a simple, this one here and this one here is a simple maths problem. You use whatever method you want, elimination, substitution, whatever.
Okay.
So let me see, when I solve that, I get X is 46.3 and Y is 39.69. That's the total mass.
So to add them.
That should equal 86. So you know how much mass is the carbon part, you know how much mass is the water part. So what you can do now is you can get the volume of water and the volume of carbon. So what's the formula for volume? Well, if you go back to the side here, density is mass over volume. So what does volume equal?
Mass over density.
Mass over density. So let's go back over here. So, I don't need to zoom out. Did I say X was water, was it?
Yes.
Yeah. So the volume of water is the mass of the water, which is 46.3, divided by the density of water, which is 1,000. So that equals 0.0463 meters cubed. And the volume of carbon is 39.69 divided by 2,000. Which is 0.019845 meters cubed. So finally, and you can tell me if you got the same answer, Karar. the density, the volume of the man is 0.0661 meters cubed. So that should be positive there. What did you get?
Well, until X and Y, everything is correct. But finally, I got the V.
Yeah, what did you get for V?
V, 15.11.
Ah, that's too big.
Yeah, but until 5 and X
Because
and Y.
15 meters cubed, that means your man would be like 1 meter by 1 meter by 15 meters.
Okay, but X and Y is the mass, isn't it?
Yes. Oh, you got these?
Yeah, I got them.
These you got?
Yeah.
Great, okay, so the only problem is just at the end.
Yes.
Yeah, so just...
86 when I add them, I get 86, isn't it?
Yes, correct, good job. So just write down this last part then.
So,
Why can't you just go straight and be like the total total volume is equals to the density, total density over the total mass over the total density. Then
We know the total mass, but the problem is we don't know the total density.
so what's the total density? Can
we
you add
get
them?
the density of water and the density of carbon.
Yeah, but how do you combine them?
Can you add
By the
them?
ratio of 7
Do you just add them and divide by 2?
No, just add them.
Just add them? No, that would be too big.
No, just add them with the ratio.
Oh, it's
Yes.
correct, but I just make it the other way around. I make 1,300 over 86. It should be 86 over 1,300.
You see, KJ, we haven't actually proven or shown that result, but that is, and that's what the result Carrar used, that if you add 30% of gold to 70% of silver, then the density is the weighted average of the two. But we have, number one, we haven't done weighted averages in maths. We haven't shown that yet in physics, so I didn't want to use it. But you can use it. It should also remind you of, if you've done it in chemistry yet, the, oh my goodness, what's it called? Calculating the mass from the ions. Have you done ions? And have you done what percentage the ions appear in each form? Like what hydrogen has 3 ions? And you've done how the percentage for each ion. And have you done how to calculate the mass? It's the percentage of the first one plus the percentage of the second one. Yeah. That process, you can do it for density.
Yeah,
But
like
I just added
relative
them.
molar mass. Relative molar mass.
That's what it's called. I forgot what it's called.
So
Relative
I
molar
just
mass.
added them.
Yes.
I just added them.
With the 70 and the 30 multiplied.
No, I just added 1,300.
Yeah.
Okay, and divided them by 86. 86 divided by 1,300. I got the same result. 0.661.
Where'd you get 1,300 from?
1,300 from 70.
Yeah, that's what I'm saying. Did you do it? Yeah, that's fine.
And this is.
Yes, that's fine. That's fine. That is fine. Okay.
And the last question.
Let's have a look.
Yes, okay, yes.
Finally.
Just 0.6.
Yeah.
If you tell us if you look like 70% of the
Yeah, no, this is the third time we're saying it. And Carrar was the first one to say, yes, if you do 70% of the first density plus 30% of the second density, that is the density of the combined total, yeah. Yeah, now we've established 3 times that works, okay? Right. A litre of an alcoholic drink, which is a mixture of alcohol and sugary sweet water, like liquid, has a mass of 976 grams. Yeah, so this is actually an interesting problem historically, is when you have a drink, how do you know how much alcohol is in it? So what do I tell you is the, this is number 5, is it? 5? Yeah. What do I tell you about it? What information do you know?
Liquid
Yeah, what's the mass?
976.
976 kilograms. What else do you know? That's all you know, is it? Yeah.
Liter.
It's a litre?
Yeah.
So you know the total volume is 0.001
Yeah.
meters cubed.
Mm-hmm.
So what you need to do is break this up into, we'll call it X, which is the non-alcoholic part, and Y, which is the alcoholic part. So And and it should be clear, x and y are the volumes, okay? Volume. So you know that x plus y, what should that equal? 0.001. True?
Mm-hmm.
Yeah. Now you also know that the density of water equals the mass of the water divided by the volume of the water. Now what's density? 1,000. Oh no, sorry, 1,030.
Yeah. Salty water.
Yeah, salty water, sugary water. Yeah. I mean, you can take them to be the same. Where was I? Oh yeah. 1,030 equals the mass of the water, which we don't know, over the volume. Now what letter am I using for volume? X. Yeah? Now, we can do the same thing for the alcohol. It's the mass of it over the volume of it. So, what's the density? 8. What's it for alcohol?
Alcohol 789.
789 equals the mass of the alcohol over Y. And you also, so that's one equation. There's another one. And you also know the total mass. So you know that MW plus MA, what should that equal? 976.
Oh yeah.
Yeah. So what I'm going to do, look here, if I just bring the X up here, and then I can bring the Y up here, I get mass of the water is 1030X, mass of the alcohol is 789Y. So you can put those two results in here, and you get 1030X plus 789Y equal to 0.976. Yeah, that's it now. Look, you have this here, don't you? Yes? And you have this one here. So, we just have to solve. So, for X, I got the volume of the water equals 7.759 times 10 to the minus 4 meters cubed. And then the volume of the alcohol is 2.241 times 10 to the minus 4 meters cubed. So I think I asked for the percentage, do I? Yeah, so we just make the alcohol a percent. So 2.241 times 10 to the minus 4 all over 7.7. Do we know the total volume? Yeah, we do. 0.001 times 100 over 1. And you get 22.4%.
Ask you a question?
Yeah.
I did it this way, but I don't know. But I have to explain to you.
Okay.
Okay. See, this is the view of the drink.
Yeah.
Drink, okay? And the M of the drink.
Yes,
like
yes,
the,
yes,
the
yes.
mixture, okay? And this is the
Density of the drink is
okay?
the mass. Yeah.
So this is the density of the drink, okay? He need only the percentage, okay, of alcohol. So I can get the percentage from the density, from the volume, from the mass. Okay?
You can get it
density, okay?
Yes.
From three of them I can get them.
Yeah, okay.
Okay, so I just make this the density of alcohol over the total density multiplied by 100.
Oh yes, no, it doesn't work like this.
Why?
So when you're getting the percentage, you have to use like mass or volume, but not density. Because imagine for a moment that the alcohol and water have the same density. That this number here would be 1.
Oh, I can get it from the mass and volume.
Yeah, but not the density.
Oh.
Because the reason for this, Karar, which is a good question, when you add when you combine mixtures, the masses add together, don't they? And when you combine volumes, they add together. But densities have percentages in them, don't they? Like what you said in the last question. So you could use this and this, but not really this, because they don't combine. Like, for example, if I have 1,000 kilograms of density and I combine it with something that has 2,000 kilograms of density, you wouldn't say it's 3,000 in total. It's a percentage between the two.
I got it.
Yeah.
It's very strong drink.
Very strong. Very strong. Okay. Yeah, so it's about 22%. Yeah. In fact, I think this question was a little bit harder than the other question, so I'm going to swap them to put this one at the end. All right, let's go on to the next lesson. That's all of them, isn't it?